Hello, welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.4, problem number 13. For problem number 13, we're supposed to make a rough sketch of this graph, and we're not supposed to use a calculator or any sorts of tools that will help us. They don't really want us to just make like a full table of values or everything. It's more so understanding how the graph works, what it looks like, and applying the proper transformations to it. So let's go ahead and start very quickly sketching the parent function, which is y equals b to the x. Y equals b to the x in general looks like this, with the point 0, 1 being the y-intercept. This is true when b is greater than 1. 0, 1 is also the intercept. If b is less than 1, it's usually something like this, and that's going to be b less than 1 greater than 0. But anyways, there's all sorts of criteria, but in general, b to the x looks like that graph in black. So here we have y equals negative 2 to the negative x. So we have a couple of transformations here. We're going to have, it'll pretty much be a reflection across the y-axis because of this negative x. Whatever we plug in, if it's positive, then it will, that's an interesting feature. I didn't know that was a thing. And then, so if we plug in a negative, let me get my signs right. If we plug in a positive x value, then this negative sign right here will just make that input negative. So what that essentially does is then negative values will become positive. So the whole graph flips about this y-axis here, okay? Then, well, what does this negative 2 do? So if naturally we have some graph that looks like this, if the graph looks like the parent graph there, b to the x, and we flip it about the y-axis, then it will look like this, about. And so that negative 2, well, what does that do? The negative sign in front of the 2 makes every output a negative number. So it just applies negative 1 to every output. And so that means that we will then reflect about the x-axis, and all of our values will become negative. So we will have a graph that looks something like this. Okay, so let's just make it a little bit more refined, and we will graph it. So we've got our asymptote at y equals 0. If x here equals 0, we'll have negative 2 to the 0, and that will just give us negative 1. And the reason why it's going to give us negative 1 is, we'll have to be careful with this because it's negative 2 to the 0, not negative 2 to the 0, right? So it's the negative value of 2 to the 0. So we'll have negative 1 here, and the graph is going to look something like this. And that's our function.